Good evening, mammals. Got a rather short screencast here that I'm going to work through some examples involving the nuclear symbol and using it to find the numbers of protons, neutrons, and electrons in an element. It's kind of straightforward, so I'll be moving rather quick, but just wanted to have this out there if you needed the support. So here's a nuclear symbol. It may have up to 3 numbers on it, but this is the only one that's mandatory, and we'll get to why that is and why the others may not always be shown in a moment. Okay, and so that number is the mass number that will always be there. There's the atomic number, and there is the charge. And you guys know that chemists are lazy. If it's just a +1 or -1, they will tend to omit the 1. But if it's plus or minus higher, anything than a 1, 2, 3, 4, that will be shown. And some definitions. The mass number is the numbers of neutrons and protons, and it is, for emphasis, not on the periodic table. No matter how close it is to the number on the periodic table by rounding, it is not the same. And that is because different elements can have what we call isotopes. These are the same element, but differ only in their number of neutrons. Differing your number of neutrons changes this part of the mass number, so the mass number will be different for different isotopes of the same element. That's why this number is the one that has to be there, because it could have multiple values for the same element. The atomic number, on the other hand, tells you just protons. This is found on the periodic table, and it's unique for each element. As far as chemists are concerned, protons are nice and cute and all of that, but they don't really do any chemistry. The one thing that they do that concerns us is they determine what element it is. But because this is on the periodic table and it's the same for each element all of the time, this number may not always be listed. Charge is your difference between the positive protons that you have and the negative electrons. So, protons minus electrons. If you have more protons than you have electrons, you will have a positive charge. If you have more electrons than you have protons, you will have a negative charge. This number may not always be shown, because if these two are equal and the charge is 0, there won't be anything shown there. So let's do some examples. So let's start filling out the chart that you will see for all of your nuclear symbol problems in class. And it's going to have mass number, abbreviated A, atomic number, abbreviated Z, protons, neutrons, electrons. So let's go ahead and start lifting some numbers off of our nuclear symbol and filling this out. The mass number, the one that is always shown, in this case is 23. My atomic number is 11. If this was not shown, I would have to look up element Na, which is sodium, on my periodic table and get it there. And I remember that the atomic number straight up tells me protons. So these two boxes will always be the same every time you fill this chart out. Now when it comes to neutrons, I have to remember that my mass number is equal to protons plus neutrons. So if I have 23 protons and neutrons, and 11 of that 23 are protons, that leaves 12 to be neutrons. So I'm just doing 23 minus 11 equals 12. Okay, I do have a charge on this one, and it is a +1. Remember that charge equals protons minus electrons, and I have a charge of 1. So I just have to think to myself, 11 minus what number equals 1? And that's 10. So I have 11 positives, 10 negatives, for a difference of 1 extra positive charge. Okay, now we've got a different symbol here. I'm going to go ahead, like I said, start lifting things off. My mass number is 18. My atomic number is 8, which means my protons are 8. I do 18 minus 8 to get my neutrons, which is 10. Now I have a negative charge, so I have to think to myself, 8 minus what number equals -2, and that number would be 10. So in this case, I have 8 positives and 10 negatives, which leaves an overall balance of an extra -2 charge. Okay, sometimes I'm not going to give you the nuclear symbol. Sometimes I'm just going to give you combinations of things down here. So let's look at this one. If I have 16 protons, that means my atomic number is 16. If I have 16 protons and 16 neutrons, protons plus neutrons equals 32, which will be my mass number. So I can start making my nuclear symbol, 32 over 16. I'm going to have to hunt on the periodic table to find my symbol, and remember that the protons, represented by the atomic number, tells you what element it is, and it's unique to the element. So be careful, don't look up the mass number to find your element. Make sure you look up the atomic number, and atomic number 16 is sulfur. Okay, I'm going to check to see if I have a charge. I have 16 negatives and 16 positives, so I have 0 charge on this one, so I just don't put anything there, and I'm done. Okay, now I've got a different arrangement here. I've given you protons, electrons, and mass number. So my protons, that is the same as the atomic number, and my numbers of neutrons, again, I'll find that by doing atomic number minus my number of protons. So that's going to be 39 minus 19, which is 20. Now I just need to make my symbol. Mass number on top, atomic number, look up element 19 on the periodic table. Remember, make sure you're looking that up by the atomic number. And that happens to be potassium, symbol K. And I check to see if I have a charge. I have 19 protons and 18 electrons. So my charge, 19 minus 18, I have a +1 charge. Last example here. In this case, I've given you the mass number, the neutrons, and the electrons. Sometimes students get a little confused on this arrangement, but again, remember that the mass number is protons plus neutrons. So if I have 56, and now in this case, 30 of that 56 are neutrons, I still subtract to get my number of protons. So 56 minus 30 is 26, which is my atomic number. Now I can fill out my nuclear symbol, 56, 26. Look up element 26. It is iron, symbol Fe. Check to see if I have a charge, 26 protons, 23 electrons. 26 minus 23 is 3 positive. Okay, guys, hope this was pretty straightforward, and we will talk to you later.